If you've ever asked somebody about the best way to design your Android app, I believe you must have come across this picture. So let's quickly try to put it to real use. Ready? Go! Any app is basically a way to show some data taken from a specific source. For example, from the network using a specific server path. It has to be abstracted away with a repository, and these two make up a data layer. The repository interface belongs to a domain layer though, or a business logic layer, in other words. So we create a repo interface in the domain, which will return the model. Model is just a fancy word for a data object that's going to be shown in the UI, like this board object that we return from the repository. And then the actual repository implements this interface and hides every detail of how this data is taken from the network, or from any other data source, because it might be many of those. And the actual data is always converted from its original form to the model, because they are not necessarily the same, like in our case. So we map the board network object to its UI representation here, in a suspended function making a network request. Then it can be passed to the domain layer for further processing. It interacts with repositories to handle specific use cases. For example, obtaining a list of boards here is a use case, which is a class that can be invoked to retrieve a list of boards from the repository. And here we can throw in any kind of business logic we want, for example, filtering by name. The process data reflects the UI state that can be monitored by a so-called viewModel, which is an extra dependency that we have to keep in our project. Then we can make our own viewModel to keep track of data changes that have to be reflected in the UI. So we make a class that implements a viewModel interface, and a few more classes defining UI states, like loading to show the progress or success when we've got the data to show. The viewModel itself needs the use case to get the state data in the first place. It also uses a state flow to monitor data changes. So we define it like so and expect the use case to return a flow of boards, which it doesn't because now it returns a mere list, so let's fix that real quick. Now it requests a list of boards and emits it into the flow. It's mapped to the success state in the viewModel when the data is collected, and to the loading state at the beginning when there is no data yet. Now it can be used to update the UI content. For that, we pass a viewModel to the composable and collect the state value here, which can also be done with this syntax. Then we check what state we've got and show the respective content here, which is a loading text in case of a loading state, or the list of boards if they've been successfully retrieved from the backend. The card element now takes the board model, because it's the actual data holder, and uses it to update the text elements. The preview has to also be changed, of course, so it renders the card with a given model. Now let's run the app and see the result. Okay, something's wrong as usual. There's a typo in the filter keyword. This time it's fine, but we can't see the loading status. So let's quickly style and position the text properly to make it more visible. And delay a server response just a little. And one last try, we see the loading state and the successful result. Guess it's been pretty quick and easy, hasn't it? Don't forget to check the link in the description to get the full code sample. Stay tuned and see you next time.